Question 6 looks at hydrocarbons, organic chemistry, crude oil, fractional distillation, all of that. It shows us a fractional distillation column. So we put the crude oil in the bottom, heat it up, it evaporates, the vapours rise, and because they have different boiling points, they will condense at different levels. It is hot at the bottom and it is cooler at the top. Crude oil vapour passes up the column, complete the sentence. Each fraction, well, condenses, we just say that, condenses at a different level. It might be helpful, actually, probably not in this question, but for future reference to label this. So we would have petrol here, refinery gases at the top, kerosene, diesel, fuel oil, and whatever else we have down the bottom here. On to the next part. So why do the fractions separate? They have different boiling points. Because they condense at different temperatures, it must be boiling points. So condensation is going from a gas to a liquid, which happens at your boiling point. Nothing to do with flammability, although they do have different flammabilities. Nothing to do with melting point, although they do have different melting points. They'll also have different viscosities, but that's not why we can use fractional distillation to separate them. It's got to be boiling points. 6.3, we have an alkane. So an alkane means it's saturated, it does not have any double bonds, and it's asking us to name it. So I know that methane is the first one, ethane the second, propane the third, and butane the fourth. So these are the only four you need to remember. So this got 1 carbon, 2 carbons, 3 carbons, 4 carbons. A good way to remember this would be to use the mnemonic many evil pussies bite. It's 1, 2, 3, so it's got to be propane. Methane is an alkane. What is the general formula? It is CN 2N plus 2, which basically tells us that if we have, for example, 10 carbons, you'll have 2 times 10 plus 2, so that's 22 hydrogens. So this is alkanes. It might also be worth noting that this CnH2n would be the formula for alkenes. So if your hydrocarbon has 1 double bond, then it's an alkene rather than an alkane, and it has this general formula rather than the one that we've just specified down here. Next we need to balance the equation. Gaps in front of everything, so it doesn't really guide us as to what to put where, but I'd be tempted to leave the carbons alone for now, see how we can balance the hydrogens over here, and then sort out the oxygens later. So we have 4 hydrogens on this side, but only 2 on here. If I put a 2 in front of my water molecule, that gives me 2 of everything here, so 2 times 2 is 4, that matches, that's good. Next I've got 1, 2, 3, 4 oxygens, so because there's only 1 oxygen in a water molecule, however I've got 2 of the molecules, so I've got 2 oxygens in total here, 2 in total here, so if I put another 2 there, that balances. So 2 here, 2 there, everything's fine. Ethene is an alkene, so we mentioned those a second ago. Those are our hydrocarbons with a double bond. They are unsaturated. The reagent that we use to test for them is bromine water. We'll go from brown to colourless. Not that one, not that one, not that one. Bromine water tests for alkenes. So life cycle assessments. So basically, how is this product impacting on the environment at any stage in its life cycle, say, to measure impact on the environment. And the next question, 6.8, says compare the two methods for the disposal of biodegradable plastic bags using information from table 6. This is good. It hasn't specified that we need to use our own knowledge, so all we have to do is use data from our table. So let's have a look at carbon dioxide produced first. So let's compare burning and using the energy to generate electricity and landfill. Well, actually it uses burning. Let's manipulate some data. It uses 25 minus 15 is 10, so it releases, oh sorry, it produces rather than uses, produces 10 kilograms more carbon dioxide, CO2, per 10,000 than landfill. Okay, so that's not great. Massive solid residue, say landfill produces, if we have a look at this data, so it actually produces more solid residue, so 0.070 compared to 0.05. And if we compare the mass of sulfur dioxide produced well, more is produced by landfill, and let's do some more manipulation. So it's actually 50% more, so the difference between these two numbers is 0.10, which is 50% of our burning. So mass of sulfur dioxide produced by landfill is 50% higher than burning. So that's not great. So as I've mentioned, all three methods, I've used data from the table and I've done a calculation. I've done some more manipulation of data, so that should get me our 4 marks.